Snow feels familiar because we see it often. That's the illusion. What we call snow is the final stage of a process that begins high above the surface, where air, motion, and temperature decide its shape long before gravity pulls it down. Once you see how snow is made, it stops being ordinary. Snow begins as water vapor, not liquid water. High in the atmosphere, temperatures are often well below freezing, and air pressure is much lower than at the surface. Under those conditions, liquid water is unstable. Liquid water only exists when its molecules move fast enough to stay flexible, but slow enough to stay connected, and that balance disappears in cold, thin air. High in the atmosphere, invisible moisture skips the liquid phase entirely and locks directly into a crystal structure. This process is called deposition, a phase change where a gas becomes a solid without ever becoming a liquid. Water vapor doesn't crystallize on its own. It needs something to cling to. Tiny airborne particles, dust, pollen, and even bits of volcanic ash act as scaffolding. Without these microscopic seeds, clouds could stay full of moisture and never produce snow at all. Each snowflake begins with a speck so small you'd never notice it. Yet without it, winter storms wouldn't exist. Once ice begins forming, physics takes over. Water molecules lock together at precise angles, creating six-sided symmetry every time. As a snowflake falls, it passes through shifting layers of temperature and humidity. Each change alters how fast its arms grow or which branches expand. Two flakes could start the same way, but the air they travel through guarantees they won't end the same way. Fresh snow is shockingly empty. Up to 95% of it can be trapped air. That's why snow absorbs sound, muffling cities and forests after a storm. It's also why snow insulates. The same air pockets that make it soft protect the ground beneath it from extreme cold. Snow acts less like ice and more like a breathable blanket. Ice itself is clear. Snow looks white because its countless surfaces scatter light in every direction. Each tiny crystal bends, reflects, and redirects sunlight until all colors blend together. It's the same reason crushed glass turns white. Snow doesn't add color. It erases direction. Every snowfall carries information. Its density, shape, and layering reveal the temperatures and conditions it passed through. Scientists read snowpacks the way geologists read rock layers. A winter storm leaves behind a physical memory of the atmosphere that created it. Snow isn't frozen rain, decorative weather, or simple ice. It's vapor-turned architecture, built in the sky, shaped by motion, and finished by gravity.